Hi, everybody. I'm Ryan Batchelder. I'm going to talk about Lambda Web Adapter, a tool that lets you build web APIs like you're used to and run them how you want to. A little bit about me real quick. I love to travel, big ice hockey fan, big Bruins fan, and I am an unapologetic aviation geek. If you see me out on the street and I'm looking up at the sky, there's probably a plane flying overhead. It's cool. I'm a technology architect at Liberty Mutual Insurance, and I have been building web APIs basically throughout my entire career in a whole bunch of different stacks. I was a one-time serverless skeptic. Every potential gripe about serverless or issue or complaints that you maybe have heard, performance with cold starts, and is it just going to become unmaintainable and all that stuff, I was like all onto all of that stuff and very much have come to the other side after some experience and playing around with it. So now I won't shut up about it. So, quick poll, and I guess for the online folks, raise your hand and we'll use the power of reverse Zoom viewing to see you. Who here has built a web API just period? AWS or not, serverless or not, anything? Okay, good number of you. For those people who put your hand up, have you done it on Lambda? And those of you who are saying yes, have you felt some pain when it comes to managing, growing that and expanding it beyond, a smaller app? Maybe, depends on how you built it. And we're going to talk a little bit about a couple of different options here. But before we get into that, I just want to kind of level set on some terminology so that we're all kind of speaking the same language here when it comes to web APIs. Really talking about like HTTP APIs that you might be connecting to from mobile app, a website, or any other number of integration points. So there's a couple of components that I'm going to talk about a lot here. First and foremost, the router. So in most web frameworks, you have some form of routing, something that when you put in my website /API/ profile, your backend knows what code to run when you're going to do that. That's what we're talking about here with the router. Middleware, these are called something different in different stacks, but conceptually, this is the thing that might happen to every request somewhere between when it's getting routed and when it's actually getting processed. That we usually do things like check your authentication if you've got like a token or a login that you got to check, or maybe we'll do some logging here to log out requests for debugging purposes. I'm going to generally bucket that into a camp called middleware here. And then the handler, that's the thing that actually does the work that your API is doing. The thing that people are paying to use your site for, or the thing that makes your app different is your handler. In a typical web framework, these have out-of-the-box sort of implementations or patterns that you can use and leverage with relative ease. So in many different stacks, you might have a router that goes off an annotation, or it's a one-liner that you might set up in like an Express.js routes file or something like that. Now, on Lambda, if we're talking the complete purist sense using Lambda, and when I say that, I mean like if we look at AWS as a collection of primitives, what are the things I would use to bring together to do the same sort of thing in AWS? So routing, we usually do this through the configuration of like API gateway or an application load balancer. It's not the only way to do it, but this is generally sort of the primary tools you might reach for. Middleware is kind of a muddy space. It was kind of a muddy space when I explained in the last slide too. But this really depends on what's being implemented. And the easiest example here that you're going to hear thrown around a lot is like the API gateway authorizer feature. And that is a feature sort of designed for one type of middleware. And this is kind of the nature of a lot of these things is you may satisfy this middleware concept with a bunch of different features in AWS. Like API gateway logging might be enough for you, or it might not be, in which case now you have to implement this somewhere else in your stack, somewhere in a function, shared library that you're going to move around, etc. And then your handler is just a Lambda function most of the time. I know API Gateway can interact and integrate with other services. We're not going to talk about that here today. We're just talking about Lambda functions. And when you put all these together, you might get something that looks like this. This diagram on the right is not an uncommon way to design a web API on Lambda. So much so that I took this straight from the AWS Serverless website. This has some drawbacks to it, but it's really easy to sort of conceptualize. We're modeling, your standard to-do application here. So you're going to store to-dos, mark them completed, delete them, all that good stuff you might do to-dos. And in this case, we have a different distinct Lambda function for each of those operations. And we'd be configuring API gateway here so that each of those operations is a distinct configuration in API gateway. This can be a little challenging to test locally because now you have a whole bunch of different tiny code bases that you have to run together or in some way to actually test out your code. Or you need an active connection to AWS. You need to actually sit there and type CloudFormation deploy, CDK deploy, whatever you're doing, and then go hit AWS, which is fine if you have a really nice, fast, reliable internet connection. Still not the fastest thing, but not everybody has that. Sometimes people are on airplanes and want to do work. And people outside the US, even within the US, it's not a given that you're always going to have that. So this isn't ideal for local testing. Code sharing gets a little bit challenging too, because like I said, now you have 6 little tiny code bases, and you've got to find a way that you might need to share common code between them. You might have a domain object that models what a to-do looks like, and you're going to need that in most of these. So now you have to find some way to share that domain object without copy and pasting it around, because then you have to update it in many different places. And depending on how you've set up your local code base, it might be a little bit more of a challenge than you might expect this to be. Runtime portability is also not great, because if you are using this setup here, and now let's say you've suddenly hit the limits of Lambda, you have so many to-dos that it takes more than 15 minutes to update a to-do. Probably have other concerns, but we've hit some limitation that Lambda is no longer the right fit for our application. This is going to be quite a lot of work to refactor, to move to a different platform, to get away from those limitations. And we've pushed a lot of complexity to the infrastructure layer. This can cause more mental overhead because it could be scattered around in a few different places. And frankly, when we're talking about infrastructure as code platforms like CloudFormation, this can get unwieldy very fast. CDK helps with this a little bit, but at the end of the day, it's still a little bit bound by some of the limitations of CloudFormation under the covers. So even solutions like that aren't great. So maybe there's a better way. And there are other options. There is what's known as the Lambda Lith architecture, which takes all of those little tiny functions and compresses them all into one. And this solves some of the problems while creating some of its own. This makes local testing a little bit easier because now we have one code base to run. I would say you can kind of do this offline now. So that's progress, although there's an asterisk there. That's a curious asterisk. Code sharing gets significantly easier. Now you're basically doing code sharing as easy as whatever your language of choice makes for sharing code and packages. Like usually it's import from another file. You've probably done this a million times writing code for any other scenario. And the routing complexity here is generally contained within the functions code base itself. Usually what you're doing here is you're configuring API gateway with a proxy route that's going to send all of the traffic to this one Lambda. And then in that Lambda, you're going to make a decision about how you're going to, what code paths you're going to invoke. But you need to handle the appropriate invocation event. What the heck is the appropriate invocation event? So Lambda out of the box does not speak API gateway. An API gateway speaks its own language in a sense. Now we're going to talk about that asterisk. So all Lambdas, whether they're driving web APIs or not, are going to be invoked with an event. This event is a JSON structure that has all of the stuff, or should have all of the stuff your Lambda needs to wake up, do whatever work it needs to do, and return a useful response. All of the AWS integrations, API gateway included, have a event structure that defines what that event is going to look like when it gets to your function. I included the API gateway one here. Don't worry if you can't read it. The point is that there's a lot here. And really, this is all the stuff you might need to handle a web request. So you've got the path in there. You've got the headers from the request, cookies. You've got the verb, and a whole bunch of other information that's in there that you now need to write code to parse through that and pull out the pieces you need, handle them appropriately to understand, I need to send the post request for this path to this function over here, and the get request goes to that function over there. And this isn't too bad, but as your project continues to live and grow and expand, one day you might need cookies. but you never handled cookies from the event before. And now you have to work backwards and find where the cookies are in this event payload, make sure your router now knows to forward them along to the handler downstream, and now update any domain models you have that represent what a request looks like going through. And now you need to do a whole lot of work to make sure you get cookies. The other component to this is now this is kind of something you have to emulate locally. If you want to run your function locally, your function is now ready to accept a payload that looks like this. Now, if you were some of the people that raised your hand at the beginning when I said who's built a web API, not a Lambda, you'll know that web requests don't look like this. They aren't just a JSON payload with all of the fields that represent a web request. HTTP looks very different from this. And this isn't something that you're going to be able to start up your whatever project, your Express app, or your Lambda function on your laptop and then open up any of the tools you're used to using for web APIs. They're not going to know how to speak this. You're going to have to find a way to take this big JSON payload and put it into your code base without API gateway if you want to run this locally. And then if at some point along this whole process, you want to use an application load balancer instead of API gateway, it has a just different enough event structure that now you've got to refactor that whole thing again. So not ideal.
Were you allowed to ask questions along the way?
Yeah,
all right,
please do.
Lambda Lift approach. I know you talked about cold starts back at the beginning of this. And so one of the things that I recall back in the early days, and I don't know if it's still a problem, is that with the Lambda Lift approach, you're making your package size of your Lambda larger versus having a bunch of small Lambdas. And back in the day, that used to impact cold starts in a way that would drive you typically to avoid the Lambda Lift approach. Has that gotten better over time, or where are we at these days?
So it has gotten a little better at baseline. And then additionally, and I'm actually going to talk about this a little bit later, but I can talk about it now too. Container image Lambdas are now a thing. You can now package up a Lambda as a container image instead of a zip file like you used to. Container images have the benefit of being able to be streamed. So your Lambda can actually start much faster with a container image and start processing while it continues to stream the rest of your code, which is feels a little bit backwards because container images are usually much bigger than zip files, but zip files are so densely packed. It has to be entirely downloaded and entirely unpacked before it can be invoked. So that is one aspect to that. The other aspect, and this is kind of just a generalization with Lambda lifts, with a Lambda lift, you have one extremely hot code path. There is one function that always runs for every handler. The likelihood of a cold start is significantly lower now because your users are all in one function. So you are far more likely to have that one function warm. Whereas
with regular traffic.
With regular traffic, right. With a fanned out approach, you may have hot and cold code paths that some of your traffic is getting a good experience. And then if somebody goes to a colder page or endpoint that isn't used as often, they're going to feel more cold start impact. So there's a couple of trade-offs here. That's something that you have to think about when you're designing your API. But I don't know how far back you were talking, but I think in general, both sides of that are significantly better now. Not gone. It's never zero. So anyway, in all of this, me as somebody who has built many APIs in the past, I just want to take my API and I want to put it on Lambda and get all the benefits of horizontal scaling, not needing to manage my operating system, and all that other good stuff that comes with Lambda. And that's where Lambda Web Adapter comes in. So Lambda Web Adapter is a tool built by AWS. It's under their AWS Labs sort of program that basically manages a whole web server inside of Lambda for you, sort of, we'll get there, and converts all of those AWS native event payloads into plain old HTTP requests. LWA is designed to be very fast and lean. It's built in Rust. So even though it's going to add some amount of startup penalty, we can't get this for free. They have taken performance seriously and want to minimize that as much as possible and ultimately make that a trade-off that makes sense for you to make. It's packaged as both a Lambda layer and a Docker stage, so you can use both zip file packaging or container image packaging, depending on what makes sense for your function. The benefit here is that it lets you use the same tools you're already familiar with, but run them in Lambda. What Lambda Web Adapter does at a really high level is it starts up whatever web server you want, and then it will forward the request into that web server. So I'm going to show us an example of this in a minute. We'll actually take a look at some code for one, but at a really high level, let's say you have an Nginx server that fronts anything. And when that Nginx server starts up, it starts listening on port 8080. Lambda Web Adapter will actually let you start up that Nginx server, and it will forward whatever request to Nginx and let Nginx handle it for you and run it within a Lambda context. So this means that you can take any technology you used before to build web apps, so long as you can start it up into a server that takes requests, which you can do on your laptop. It will start up and run those the exact same way in Lambda. One of the big benefits here is, besides simplifying a lot of things, is it also gives you runtime portability. You no longer need to have any Lambda specific code in your handler. You just have kind of bare bones infrastructure configuration. We'll take a look at a CDK stack that deploys one of these. And you could decide that you want to pick that function up and throw it into a container on some other, orchestration platform. You want to go throw it on a Raspberry Pi in your basement. You don't have to rewrite any of that code. You can move it around to whatever runtime platform makes sense if you get to some stage where Lambda isn't working out for you. On top of all this, it actually does provide a mechanism to integrate event-driven invocations right into the same code base. And I know this is a little bit of a loaded word because I talked about event-driven before, but what I'm talking about here is, let's say you have a queue or like an event bridge that you want to send asynchronous events to your same code, and you don't want to deploy a separate function or rewrite anything. You can actually set up an endpoint that and tell Lambda Web Adapter, hey, send any async invocations to /events. And it will forward those automatically, so you can continue to write just your, the web API framework you're used to and still receive and process those events. Demo time. Any questions before I jump into the demo?
I have a question, but if you're going to get to it later, you can tell me that.
Okay.
So one of the things I love about, Lambda's fulfilling API requests is that I get to leverage the AWS Lambda metrics. So for example, if there's an error in my code, I throw that error and all of a sudden I have an AWS metric for lambda.errors, whatever it is. Do you still get any of those benefits with this approach where you're triggering the AWS namespace metrics, or is that something that you have to roll your own?
As far as errors in specific, I would need to check. I believe you need to implement that yourself.
Okay. Lambda
Web Adapter does try to do some things for you to manage that, but I'm not 100% sure actually now how errors come through. And this doesn't directly answer your question, but it's sort of a related tangent that I think is important. Whatever web framework you're using, you can use whatever mechanism is native to that framework to return HTTP error codes as well. So if you need to return something other than a 200 class, like a 500 class error, when you send that back, that will get cascaded through correctly. You don't have to do any gymnastics with converting that into the proper event that API Gateway knows how to interpret and forward along in the proper HTTP code. So I know that part doesn't answer your question, but I think it's kind of related that you can use monitoring that you might use for any other web API, and it will react in the same way as if you were running that same code in EC2 somewhere.
Awesome.
He just doesn't have errors in his code.
That's what I heard. That's what I heard. Yeah. Errorless API.
Yeah.
So I assume that a Lambda Web Adapter is cheaper than running, a dedicated server or whatever. How much cheaper is it? And is there a break-even point type of thing?
Okay, so this is a question that we could probably go into for a long time, but at a high level.
Sure.
So Lambda Web Adapter itself is the service itself is free, so we'll kind of put that aside. The Lambda service, you are only billed for the milliseconds it is invoked. So you don't pay anything at all until the second you get a request. Your Lambda wakes up, runs for say 500 milliseconds, and then shuts down. You only pay for that 500 milliseconds of execution time, which is ridiculously cheap. And the free tier is quite high for that as well. I don't know what the break-even point would be, but it would be extremely high I would think, like a high number of invocation or a lot of invocation time before you got to the point where the smallest EC2 instance was at break even. Does that sort of answer your question a little bit?
So I'm thinking a monolithic application would still want to do it the traditional way, but if it's a kind of a one of type thing, then
it depends on your traffic load. So if you're getting a ton of constant traffic or really, really high burst traffic, it might be cheaper to run it on an instance that's always running. But if you have a lot of downtime or you have lots of time where your server would otherwise be doing nothing, more than likely Lambda is going to end up being cheaper because you're only paying for the exact time you are doing useful work. Whereas like with an EC2 instance or a traditional server, you're paying for all the time that people aren't using it. Unless you shut it down, of course. But typically with a web service, you want that available all the time because you don't know when a customer or user is going to come and land on your service and use it. But you probably know that, many hours throughout the day or at night, it's pretty quiet. So you don't need to worry about any of that scale and any of that, shut down, turn it back on, anything like that.
And just on the note of cost per invocation, that was one thing that when you were talking about ways to test this, you can test by invoking out in AWS, assuming you have an internet connection, but it does cost money. There is the free tier, and you're more than likely going to stay within the free tier. But if you aren't within the free tier, just testing your application now costs you dollar bills, where running it locally and testing it locally didn't cost you money. And so that's a consideration to make. Even if you have that internet connection, testing might not be free anymore, which is a strange concept.
So I guess a follow-up to that would be, has anyone started to write an emulator?
An emulator for which piece?
To emulate, say, the Lambda Web Adapter, so it could be standalone.
So Lambda Web Adapter actually aims to help you bring your standalone code. I will say there are services, Local Stack is a really common one that tries to emulate a lot of different AWS services, Lambda included, that you can run on your laptop and use to try to emulate what's going to happen in AWS so you can try to test for free. In my experience, it's not always perfect. And sometimes you can run into issues that only present themselves in Local Stack and spend a lot of time trying to debug a problem that wasn't a real problem, wouldn't have manifested in a real environment. So they exist, and Local Stack, I think, is a premium product now. There's certain services offered for free, and if you want all of them, you've got to pay. So there are solutions out there, but they're not great. What this tries to do is tries to bring you all the way back and say, instead of emulating everything in AWS, what if we made Lambda look like what your servers used to look like? So it kind of flips it on its head a little bit. Okay, so what I'm going to show here is this is a Python Flask app. If you don't know Python or Flask, I'll walk through what is going on here, but there's not a whole lot of code. It's pretty easy to parse through, I think. This is a TypeScript CDK stack, so we're going to actually start from the stack itself, and I'll just kind of walk through the couple of pieces here. For those of you familiar with Lambda and using CDK to deploy, this is probably going to look really familiar because there's not a lot here. There's very little that's actually unique to Lambda Web Adapter, which is really nice. It's actually really easy to bring into your project. So first and foremost, we're deploying our function here. This is the Python function I'm going to show the source for in a second. This is the CDK construct that wraps over the Lambda function. So if you aren't used to Python, but you are used to Lambda, all this does is a little bit of extra magic to help with packaging dependencies. Nothing Lambda Web Adapter specific here. We've got just your standard sort of function name, entry, and index. I will note that some of this is required for the Python function construct to work, and I do have to do a little bit of escape hatching for the handler. Lambda Web Adapter, we're going to initialize with a shell script, which is actually going to start my server. CDK tries to save me from a potential error here where my handler should, that hint to go away, where my handler would normally need to reference a source file. So it would try to actually glue the index to the front of my handler. We don't want that to happen. So that's all that's happening here is I'm just kind of escaping out of that and saying, CDK, I know what I'm doing. Please set this to run.sh. This is not a problem in CloudFormation, serverless framework, SAM, things like that. Runtime, we're just doing a standard Python 3.11 running on Graviton. I've just set an arbitrary memory size here, nothing too crazy. This layer is the first place we see some Lambda Web Adapter specific. And I'm sorry, I know I have to scroll out to show the whole thing here, but I'm using zip packaging here because this is a really tiny function. And I've packaged this using the layer provided by AWS for Lambda Web Adapter. So this account number here is an AWS account, and they provide this full ARN on the GitHub. There's a different one if you're using ARM or x86. So you could totally use this with standard x86 Lambdas, no real change besides specifying here. The environment, there's a couple of fields that might look unique here. The exec wrapper, this is just a way to customize the Lambda execution context. This isn't really Web Adapter specific, but it is required by Web Adapter. You may have seen this if you use certain monitoring tools or things that customize the execution environment to inject some code to do monitoring. This bootstrap script does come from the layer. I did not write this. It's provided by Lambda Web Adapter, and that's how they sort of customize the execution context to start up the adapter and then start my server. The other two here these are actually the default values. I didn't need to pass these, but it gave me an excuse to talk about them. There's a couple of environment variables prefixed with this AWS_LWA that let you configure Web Adapter. So the first one here, readiness check path, is basically the endpoint that Web Adapter is going to be trying to hit repeatedly on my server to know when it's up and ready to take traffic. So if you've ever built using like a load balancer or target groups, and you're familiar with writing health checks to tell the target group when a target is ready and healthy and can be forwarded traffic to, or container orchestration platforms have this concept as well. That's basically what's going on here. Lambda Web Adapter holds my real request until the readiness check path comes up and gives a non-error request, and then it forwards the real request through. Then the port is just the port my server is going to run on. I set it to 8080 here. You could set it to whatever makes sense for you or your stack. The rest here, this is just Python specific. I'm excluding my virtual environment. And then the last thing I wanted to show is this API gateway configuration is 4 lines. Really, it's kind of like 2 lines. All we need for API gateway to make this work is a proxy endpoint that's going to go to our handler function. Lambda Web Adapter does support load balancers and the newish Lambda execution URLs, where you can get just out of the box an execution URL that goes to your Lambda. So if you're using those, you can use that here as well and skip the whole API gateway. I just wanted to show it because API gateway has kind of been around the longest as the tool of choice for building APIs in Lambda. And now after all that, we'll actually look at some code. So this is my app. There's 2 endpoints here. This is 100% pure Flask code. There's nothing Lambda specific, nothing Lambda Web Adapter specific, nothing AWS specific. If you have written Flask, this is going to look familiar. If you haven't, this might still look somewhat familiar if you have web API experience, because Flask looks fairly similar to like Spring Boot in some ways that it does things like routing. So this here is a Python decorator that tells the server anything that comes to / just the root endpoint, run this function down below. Down here, I have a different endpoint called /secrets that accepts post requests. And you can see here how that looks a little bit different than the one above, but this is the same thing. When somebody comes to the API and sends a post request to /secrets, we're going to call this function down below it instead. And then I've included a couple of things here just to kind of show off how this works just kind of seamlessly. This does absolutely nothing useful, and we'll show it in a second, but we're just going to do a kind of the most convoluted hello world I could come up with. But in the process, I wanted to show, what if I need to get cookies? Well, in Flask, you go to the request object and you get the cookies dictionary. And that's all I'm going to do here. Headers, basically the same thing. And then even query string parameters. So the things when you have, your URL ? Some parameter equals some string that you want to query against. Same thing in Flask, you just go request.args, and then it gives you the different variables in a dictionary. And here I'm just going to actually look for the presence of one. And then based on all of those different things, I will add some additional things to the response. Nothing terribly exciting. All of this, I can come to my terminal here and make it more legible. I can go into the directories. This is where that app.py file is. Haven't done anything crazy here. Make it big enough. And I will run Flask run locally. This is what I would do if I was building this application on my laptop and I just wanted to test it out. Nothing AWS related. This is going to start up a development server. It's running on my local host here on port 5000. And I can open up Postman and I can go to that URL that we were just showing. I've included all the things here. So I have that query string parameter. I have an authorization header with a really secret token value. And then I've included a cookie as well. And all of these are coming through in my response. This is fairly straightforward. Really nothing exciting here so far. I hope anyway. Where this gets interesting is that was all local. If I back up, and I'd already deployed this one, so it's going to probably just do nothing because I haven't made any changes. But here, I'll even prove. We'll add a few more exclamations to this. Go ahead and deploy that again. Just now it's going to take longer. Need to install.
While this is running, question. So if we go back to the VS Code, it talks about, hey, don't run this in production. There's output in the terminal.
Yeah.
Is your run.sh script, is that?
Thank you. I forgot to jump into that. So by default, the built-in Flask server is not production grade. This is the case with a lot of web frameworks. They're sort of like built-in server will give some warning and be like, don't ever run this in production because it's built for debugging. And usually you'd use some other server to front your web app that knows how to basically mount your code. Commonly, you might use like Nginx or Apache with various modules. What we're doing here is actually running gUnicorn, which is a WSGI compliant server for, I don't even know if it's specific to Python apps, but it's used often for Flask apps. If I was running this in a container somewhere, if I wanted to run this Flask app Fargate or out on a Kubernetes cluster somewhere, I'd probably also use gUnicorn there. And so my run.shell file here is really just a couple of things to set up the Python path. These are Lambda specific environment variables, but I might just change these to point to what's inside my container if I was using a container instead. And then we're executing gUnicorn, passing it the port of 8080 that we talked about before, and then the path to my app. So yes, you could call out that we're not going to run the built-in Flask server in production. Because in this case, production is nothing terribly exciting. So did my deploy finish? Probably did. Yes, it did. Okay, so my deploy finished, and I have this API gateway endpoint here. You could try hitting it right now if you can type it really fast.
Do you want to read it to me?
We saw where that got us already once today. And if I hit that endpoint here, we can see I added a couple of exclamation marks in the code before, so that actually did work. And I'll pull this up in the AWS console as well, but I just took the server exactly as it was running on my laptop and I shipped it straight to Lambda. And with the cold start, in this case, I waited just over a second to run. The second invocation is in 120 milliseconds. I paid for 120 milliseconds just now, and that's it to run a whole web server.
Right. So to kind of circle back on that earlier question, to do the local testing, the point is you don't need to emulate LWA.
Exactly.
You take it out of the picture.
Yeah.
Because it's just standard HTTP.
Exactly.
Yeah.
Yeah. All Lambda Web Adapter is doing is taking whatever AWS is doing at the API gateway or function URL or ALB level and translating it into regular old HTTP that the server I've written and tested locally knows how to interpret and respond to. And it makes the entire interaction for my code happen in HTTP. HTTP request comes in, I do some work, I give an HTTP response back. Lambda Web Adapter does all the magic in the middle to make that integrate nicely with all the AWS services that are going to get touched along the way before it gets back to me or back to my requester.
So there's a lot of testing that you can do without it, which is not to say that you shouldn't test with it.
So you would test with it, in your deployed environment,
right.
But you can test basically everything you would have done just fine locally. Right. And we have actually found in at least one case, potentially uncover bugs that you may not have uncovered previously in weird edge cases where you may have some code that does not respond well to an execution environment that lives for multiple requests. If you use sort of the traditional method of build a function, run it once to test it, and then that's it. And however you run it, however you pass that event in, that's not exactly what happens in Lambda. Because in Lambda, the code starts up and it runs, and you get billed for the time it runs, then it returns. Your billing ended there. AWS doesn't stop running your code, though. They leave that, we were talking about cold starts earlier, they leave that execution environment, quote unquote, warm for some period of time. That period changes all the time as defined by AWS and is a tightly guarded secret, but on the order of minutes. You can expect that there is a server somewhere that is running and has your code downloaded to it and ready to go for the next request that comes in. If your code doesn't properly handle existing still through 2 requests, you might have a bug. When you use something like Lambda Web Adapter, you'd find that really fast because you probably are going to make multiple requests on your laptop in the course of testing and building things. But if you're testing using like an emulated environment, using local stack or just sending a JSON payload somehow manually, however it makes sense in your stack, you're typically starting up that code, doing it, and shutting it down again. You're emulating a cold start every time, not what actually happens in Lambda. So this can actually help in some ways. Now that's general edge case sort of scenario, but it is a potential thing that could happen. So the only thing I wanted to pull up here and show in the console is just that I haven't done any there's no magic happening besides what we've already shown. The code here, these are all just the dependencies that got packaged up. These are all like Flask and GUnicorn related. If we look into my LWA demo API and app, and I will zoom in so that you can see, this is the exact code we were just looking at, although I didn't refresh since I updated it. So let me do that. And I think it's giving me a cached version of that because we just saw the response definitely had 3 exclamation marks in it. But the code is here. I don't know why this is giving me the old function. There we go. It was just cached. So this is the same code we were just looking at. The last thing I want to talk about before we jump back to the slides is this other post request that I have in here. Less about the request itself and more that I mentioned before, status codes. So HTTP requests have a status code that indicates if it's a success, an error, things like that. I mean, there's different levels of success. So for this post, I just made it return a 201 instead of a standard 200. This multi-return, returning a tuple, is exactly how you do it in Flask. It's a common pattern in Python. And if I go and make that post request to my endpoint, it did come back with the proper 201 created. I didn't have to do anything to tell API Gateway how to handle that. Okay. The button is hiding under the bar. Hold on. Okay. So this seems cool, but why wouldn't you use Lambda Web Adapter? So for really simple services, this might be more than you need. If what you need to do can be easily done in like a single source file, and you don't need of the overhead of building up and running a server, then like just do what you were doing before. You don't have to do this for everything. The rest of these points are going to kind of get to the performance aspect. So not all web frameworks start up fast enough to justify the performance penalty of starting a server and then doing some work. Flask is super fast. There's even faster ones like Fast API in Python. Express.js is pretty fast. And there's a whole bunch of other ones out there. Folks who use like Golang's Gin, that's a pretty quick one as well. These are all pretty good options. You probably don't want to start a fully hydrated Spring Boot app that uses a ton of dependency injection and reflection, because those are fairly slow. If you're building truly super latency critical apps, you may not be able to meet your performance targets with an architecture that looks like this. At the same time, a lot of those aren't always going to fit Lambda that well in the first place either. So that might have already ruled you out before you even got here. And larger functions can cause overall slower startup time, to your point earlier, Chris. Lambda Web Adapter causing you to bring in a server is going to naturally cause you to inflate your code size because you're now bringing a server along in your deployment package when before you weren't. Different servers are going to have different size penalties, but container images can help with this. And I've linked here, I think we can share the slides after somehow. Okay, so you can click that link and go to it, to a great post by AJ Stuyvenberg, get through his name, benchmarking the differences between zip and container lambdas and where sort of the break-even point is, where a container image starts to become quicker than your zip packaged function. But if you've made it this far, why would you use this? So to kind of sum up a lot of the things we've talked about, Lambda Web Adapter helps you move the complexity away from your infrastructure and into your app code, where it's easier to test both in an automated and a manual way. You can write automated tests against things like how routing works, and you can manually test it, of course, as well. I did that here. I started up my server and I started to use the server as it's going to happen in Lambda. You can stand up local environments that accurately reflect how your app will be run without all of those additional emulation layers. So you don't have to go learn all the emulation layers if you already know how to build a web app in any of the frameworks that you may have been building in before. You get portability. So now that we've moved all that complexity out of the infrastructure and down towards our app code, we can pick that up and move it to a whole bunch of different places really easily. So if that doomsday scenario happens and AWS chooses to raise the prices like crazy and Lambda suddenly costs $1 per millisecond, we could just pick up our function and go run it on a Raspberry Pi in your basement, or go take it to an instance in Azure, or wherever you want to go move it to that makes sense. You don't have to do any major refactor work now. This works two ways too. So not only can you move your application out somewhere else, it's actually really easy now to also migrate an existing application into Lambda using this. So if you already have a web API that's out running in Fargate or EC2 or somewhere else, with almost no code changes, besides maybe setting up a shell script to start up a server, you could try running this on Lambda and see how it performs. You don't have to change the actual app code at all. You just need it to be running a server on a port, and then Lambda Web Adapter can take care of the rest. You can put it out on Lambda, see how it performs, and if it performs well, potentially save a boatload of money over how you're running it before. And one that I think it's a little bit softer, but it's really, really important, is you can reduce the learning curve for yourself or for your team that's looking to deploy to Lambda. If you've got a team of folks that has been building .NET Core APIs for years, you're all experts in that. Excuse me. You're all right at the end here. Put it together. All right. You're all experts in building .NET Core APIs or Express.js apps, and you've been deploying them to container platforms for years, but you're thinking, hey, managing this container platform is kind of a pain. It's expensive. I got to stay on top of operating system updates for the underlying instances all the time. Building these containers takes a while, all this kind of stuff. You can try out deploying to Lambda without everybody in your team having to go learn how to build for Lambda. You can take all of those skill sets with you and still use Lambda just as a deployment runtime target, not as a whole new way of architecting your apps. You can build the same way that you always have and just deploy it the way that you want to. Any other questions?
So this one came in on chat.
Yeah.
I promise it's on my. Does the Lambda Web Adapter Lambda layer itself have any performance implications? I've ran into issues in the past where adding custom layers to our Lambdas causes severely increased cold start times, such as the Datadog APM. I wonder if cold start benchmarking has been done with this versus serverless express or raw HTTP event mapping.
Okay, so I think there's a few things in there. So Lambda layers do have a startup penalty because they add to your overall code size. Any code that's in that layer needs to be downloaded to the execution context and unpacked and ready to go. So it should have a similar effect to if you had taken everything that's in the layer and dropped it into your zip file. So you aren't going to get that for free. As far as the layer versus the zip file itself, they should both be stored in S3, so they should be relatively similar in terms of it shouldn't be dramatically different using the layer versus if you had pulled that code into your artifact. There are other frameworks that do similar things to Lambda Web Adapter. So that one of them you mentioned in there, Serverless Express.
Yep, Serverless Express or just the raw HTTP event mapping.
Yep, and there's a handful of other libraries like Serverless Express that try to do a similar thing to what Lambda Web Adapter does. Used one for years in the JVM world. The difference there is they're not agnostic to the framework. So I couldn't come up here and tell you, take any web API framework you are used to building in and then go throw it into that tool. They're typically built specifically for a specific framework, and they've had varying levels of support over the years. Actually, many of them have now been deprecated and now point to Lambda Web Adapter as the replacement. Doing raw HTTP event mapping is just going to be faster. But the point here is you don't want to have to maintain that additional code. But that is going to be your zero dependency way of handling this because you're getting the raw invocation event and you're translating it on the fly to do what you need to do. But you have to weigh is a couple of milliseconds of performance impact worth it for all of the additional productivity, the reduced sort of mental overhead of keeping track of how all this code works together, all that stuff, the ease of local testing, things like that. That's a decision you have to make for your application. Most of the time, I would argue that performance penalty is worth it, but I can't speak for what you're building. I think I got all the parts of that question, right?
I think you did as well. Turner, thank you for the question in the chat. If you want more clarification, just let us know.